Alright, so this is H2O, also known as water. It's the central oxygen with 2 hydrogens bonded to it. There are 8 total valence electrons. There are 2 lone electron pairs, and since there's the 2 bonds, there are 4 total electron domains. This means it has an ABE equation of AB2E2 and then a bent tetrahedral shape. Its bond angles are 109.5 degrees. Its hybridization is sp3, and since the charges are asymmetrical, this is a polar molecule, and there are no resonance structures. Okay, so this is hydrogen cyanide. It's a central carbon atom with triple bonded to a nitrogen and single bonded to the hydrogen. It has 10 total valence electrons. Because there's the 2 bonds, it has 2 total electron domains. There are 0 lone electron pairs on the central carbon, so the AB equation is AB2. This means it has a linear electron domain geometry and molecular geometry. Its bond angles are 180 degrees, Its hybridization is sp, and since the charges are asymmetrical, this is a polar molecule, and there are resonance structures for it. Alright, so this is ammonia. It's the central nitrogen, 3 hydrogens. It has 8 total valence electrons. There's the 1 lone pair of electrons and the 3 bonds, meaning it has 4 total electron domains. Its ABE equation is AB3E. Because of that, its electron domain geometry is tetrahedral, and its molecular geometry is trigonal pyramidal. It has bond angles of less than 109.5. Its hybridization is sp3, and since the charges are asymmetrical, this is a polar molecule and it has no resonance structure. Alright, so this is CF2Cl2, also known as a chlorofluorocarbon. There are 32 total valence electrons as it's the central carbon, 2 fluorines and 2 chlorines. There are no lone electron pairs, so there's only 4 total electron domains. It has an ABE equation of AB4. Because of that, it's a tetrahedral electron domain geometry and a tetrahedral molecular geometry shape. It has a hybridization of sp2, and it's symmetrical. The charges are symmetrical, so it's a nonpolar molecule, and there are no resonance structures for this. Alright, so this is BF3. It's a central boron with only 3 fluorines attached to it. There are 24 total valence electrons. It has the 3 bonds and no total lone electron pairs, so there are 3 total electron domains. Because of that, its ABE equation is AB3. It has a trigonal planar electron domain geometry and trigonal planar molecular geometry. There's a hybridization of sp2. It has a symmetrical, its charges are all symmetrical, so it's a nonpolar molecule, and it has no resonance structures. Alright, so this is SCl4. It's a central sulfur atom bonded to 4 chlorines. It has 34 total valence electrons. It has 5 total electron domains because there are the 4 bonds and then the 1 lone pair of electrons. It has an ABE equation of AB4E. Its electron domain geometry is trigonal bipyramidal, and it's a seesaw. Alright, so it has bond angles of 180 degrees, 90 degrees, and then 120 degrees. It has a hybridization of sp3d, and since the charges are asymmetrical, this is a polar molecule and it has no resonance structure. Alright, this is sulfur dioxide, SO2. It's a central sulfur atom, double bonded to 2 oxygens. It has 18 total valence electrons. There's 1 lone pair of electrons and the 2 bonds to the oxygens, so there are 3 total electron domains. This means its ABE equation is AB2E. It's a trigonal planar electron domain geometry and a bent molecular geometry shape. It has hybridization of sp2, and since the charges are asymmetrical, this is a polar molecule and it does have resonance structures. So this is sulfur dioxide. It's a central sulfur atom with 2 oxygen atoms. As you can see, they're both double bonded. There is 1 lone pair of electrons, so there are 3 total electron domains. Its ABE equation is AB2E. It has a trigonal planar electron domain geometry and a bent molecular shape. It has bond angles of less than 120 degrees, and its hybridization is sp2. the charges are asymmetrical, so this is a polar molecule. And there are resonance structures for this molecule. Alright, so this is phosphorus pentachloride. There's the essential phosphorus bonded to 5 chlorine atoms. There are 40 total valence electrons. There are the 5 bonds and no total electron pairs, meaning it has 5 total electron domains. The AB equation is AB5. It has a trigonal bipyramidal molecular geometry. It has bond angles of 90 degrees and 120 degrees. It has hybridization of sp3d, and the charges are symmetrical, meaning this is a nonpolar molecule, and there are no resonance structures either. Xenon tetrafluoride. It's a essential xenon atom bonded to 4 fluorines. There are 36 total valence electrons. There are 6 total electron domains because there are 4 bonds and 2 lone electron pairs. Its ABE equation is AB4E2. It has an octahedral electron domain geometry, and its molecular geometry shape is square planar. Its bond angles are 90 degrees, and its hybridization is sp3d2. The charges are asymmetrical in this molecule, so the molecule is polar, and there are no resonance structures. Alright, this is iodine pentafluoride. It's the central iodine bonded to 5 fluorine atoms. It has 42 total valence electrons. There are 6 total electron domains because there are the 5 bonds and then one pair of electrons. The AB equation is AB5E. This means it has an octahedral electron domain geometry and a square pyramidal molecular geometry shape. Its hybridization is sp3d2. It's asymmetrical, meaning that this is a polar molecule, and there are no resonance structures. Alright, this is carbon dioxide. It's a central carbon atom double bonded to 2 oxygens. It has 16 total valence electrons. There are the 2 total electron domains because there are no lone electron pairs. The AB equation is AB2. It has a linear molecular geometry. Its bond angles are 180 degrees. Its hybridization is sp, and this is a nonpolar molecule because the charges are symmetrical. And there are resonance structures for this molecule because of the double bond. So this is BRF3. It's a central bromine atom bonded to 3 fluorine atoms. There are 28 total valence electrons. It has 2 lone electron pairs and the 3 bonds, meaning that there are 5 total electron domains. This means it has an ABE equation of AB3E2, and then its electron domain geometry is trigonal bipyramidal, and its molecular geometry is T-shaped. It has bond angles of 90 degrees and 180 degrees. It has a hybridization of sp3d, and it is asymmetrical, so it is a polar molecule, and there are no resonance structures for this one. So basically in this project, I learned about the Vesper model, which is the valence shell electron repulsion model, and how each covalent bond and each unpaired electron is an electron domain, and the best arrangement of electrons in a molecule to minimize the repulsion between them depends on the amount of electron domains in the surrounding the central atom. And I learned how the atoms do this by minimizing repulsion using hybrid orbitals. And I also learned about how just the dipoles of the charges would make it symmetrical or asymmetrical depending on the arrangement in the Vesper model, and how if it's symmetrical that means it's nonpolar, and how if the charges are asymmetrical it is polar.